Hello, this is Jennifer Martinez. In this video, we're going to look at an application using approximations of trig values. We're going to look at an example here on finding the grade resistance. So let's go ahead and read this. When an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force in pounds is the grade resistance and is modeled by the equation F stands for force here, equals W. If you read below here, W is the weight of the automobile times sine of theta, where theta is the grade. If the automobile is moving uphill, then theta is greater than 0. If it's moving downhill, it's less than 0. You can see the figure below here. And this is a real-world application. Here's the source if you're interested in checking it out. So part A, calculate F to the nearest 10 pounds for a 2,500 pound car traveling uphill at a grade with theta being 2.5 degrees. So let's go ahead and do this. Since F equals W sine of theta, that's our formula. F, if you remember, is the force. W is the weight, and theta is the grade. That is the degrees from the horizon going up, or the degrees from the horizon going down. And we want to find the force when the weight is 2,500 pounds and the grade is 2.5 degrees. So plugging this into our equation, we can put here the weight times sine of 2.5 degrees. Since it's 2.5 degrees, it's not one of our special angles, so I'm just going to use my calculator. So let's go ahead and do that. When we use our calculator, we need to make sure that we're in degrees. There's going to be two modes, radians, which we're going to see in the next chapter, and degrees. So the first thing you want to do is go to mode and make sure your calculator is in degrees. Mine is in radians. So I'm going to go down here and to this fourth line here and see how it's blinking. I'm going to press my right arrow here, right there. Press that right arrow. And now it's on degrees. When it's on degrees blinking, I'm going to press enter. So that way the degrees will end up being the one that's highlighted, that's black. There it is. So now I'm in degrees. So to get out of this, you're going to go to second quit above the mode. This is, by the way, using the TI-84 calculator. If you have a different calculator, it might be a little bit different. But this is the calculator we're going to be represented in this class. 2,500, then I'm just going to type in. I see the sign right there. I'm going to press sign, and I'm going to say of what? 2.5. You don't need the degree sign. Just in the parentheses, press enter, and there it is. About 109. F is about 109 pounds. To see why this works is a physics problem. And in physics, you will find that you can see when a car is going uphill, there's going to be a force wanting to push it downward. So the force is going to go this way. And there's a weight. The weight is going downward. That's the force of the weight. And you can see it makes a right triangle. There's a right triangle right here. And this angle, I'm going to enlarge this. And this angle right here, the angle, believe it or not, is this angle right here. You can kind of see that because this angle, if I do this green triangle, that's the same triangle. And this angle would be 90 degrees from, it's the same triangle from this one. So these two angles have to be the same. This angle and that angle is the same. These two. And this is a right triangle again. So if I redraw that, you will see that sine of that theta is the opposite, which is the force over W, or multiplying both sides by W, F would equal to W times sine of theta. We have it. So that's how they got the formula, in case you're interested. So let's do part B. So let's go ahead and calculate the force to the nearest 10 pounds, same thing, for now a 5,000 pound truck traveling downhill. So the grade is negative 6.1 degrees. So now the weight is 5,000 and the angle is negative 6.1. So again, using our calculator, we can just plug this in. We're already in degrees. That should not have changed, but if you want to check it, you can go to mode. You can see its degrees is highlighted. So I'll go to second quit and I'll just type it in. 5,000 times sine. Again, we need to use our calculator because this is not one of our angles that we have memorized. It's not one of our special angles. So the only way you can find that is using a calculator. And there it is. It's a force negative 531 pounds. They did ask for the nearest 10. I just realized that. So this is negative 530 pounds. That would be to the nearest 10. And this one up here would be 110 pounds, the nearest 10. I did to the nearest one. Okay, let's do part C. Calculate the force for 0 degrees and 90 degrees. Okay. For theta equaling 0 degrees, it doesn't even matter what the weight is because we know the sine of 0, you could try it on your calculator, is 0. So the force is 0. For sine being 90 degrees, we do not know what the weight is, so I'll just keep it W. Sine of 90 is 1. You can check that out as well. So the force is going to be the weight. And this does make sense because if you had a car, a horizontal car, here's my car, there would be no force pushing it downward. And 90 degrees, what would that mean? That mean I would have a car, wouldn't even make sense. Going up a steep incline, here's my car, and the force would be the same as the weight. You just pull it straight down. Here the force would be 0, the little tiny 0 force, and here the force would equal the weight. And that would be part C.